Hi everyone, I want to go through an example that I solved during our exam prep session. I have had the students contacting me and asking about this question. I also made a little mistake in one of the section of this question. So I want to clarify that and I want to make sure everybody is comfortable with this question. So we have a stationary wire. Let me explain the example. We have a stationary wire. Our stationary wire is basically represented like this. And you have a rod, a moving rod, MN, and that rod is moving down. You're given the length of the rod, 3 centimeters. Converting it to meters would give me 0.03. The magnetic field, this whole system is inside a magnetic field that is pointing into the page. You guys can see that. The magnitude of the magnetic field is 7 times 10 to the power of minus 3 Tesla. By moving the rod down, which end of the rod is at a lower potential and which end is at a higher potential? That is part A. And part B, in which direction does the current flow? They actually mean in which direction does the current flow, does the induced current flow through the resistor? Because if you look at the straight wire, it is not connected to a battery, so there is no current. But moving the rod down, you guys see that this rod being here is creating a loop in here. So if you have a loop and moving this down, you're increasing the area of the loop. Let's say if you're taking it up to here, this is going to be your new area. Increasing the area means that you're increasing you're increasing the magnetic field, or you could say more of the area is exposed to the magnetic field. Therefore, the loop will create an induced magnetic field that would oppose the actual magnetic field. So if the actual magnetic field is going into the page, the induced magnetic field will be coming out of the page, and it's represented by dot. Now, putting your thumb in the direction of induced magnetic field, curling your forefingers should show the direction of the current. So I am going to show you the direction of the induced current, which is going to be, using my forefingers, which is going to be going counterclockwise. Yeah. So remember, when you're using your right hand rule, you could have your thumb in the direction of magnetic field, curling your forefingers in the direction of the current, or you could switch them. You could have your thumb in the direction of the current, or curling your forefingers will show the direction of the magnetic field. Either one would work. So knowing that, I can answer part B. I can say, look, the solution for part B would be that current flows counterclockwise through the resistance. Perfect. Now I want to answer actually part A. Which end of the rod is at a lower potential? In the circuit context, we have learned that when a current is flowing through a resistor, the voltage across the resistor would drop such that this end is going to be the low voltage point and this end is going to be a high voltage point. So remember, it is just the resistance that is causing a voltage drop. Just the resistance. That means that point M, which is right below, which is directly below that low V, it will have low voltage as well, the same low voltage, because there is no device between the top point and this bottom point, which is point M. Similarly, point N will have the same high V as the top point, high V, because there is no device between this point and this one in here. So we can see that here point M has a lower voltage than N. So I could say M has a lower voltage. Okay, so this one is the small mistake that I made. Now, if the speed of the rod decreases, what happens to the current? This is part C. If the speed decreases, what happens to the current? In the previous video, I mentioned that when you are changing the area, the equation that you would use for induced voltage would be basically BLV. And having the induced voltage, to find induced current equals delta V over over R. So induced current comes from induced voltage, reminding you that V is the small v representing the velocity of the rod or the velocity of the loop. Now, if you decrease V, if you decrease the velocity, the induced voltage will decrease. Decreasing the induced voltage would decrease the induced current. So I can look at the equation and I can both equations and I can say, look, I induced decreases. If the current through the 50 ohm resistor is 2.5 times 10 to the minus 6, what is the induced voltage? Now for the next part, the answer would be, well, look, if I want the induced voltage, I have I induced and I have R, I can just sub in the numbers. I would be 2.5 times 10 to the minus 6 and R is 50 ohm. If you do that, you will end up getting delta V being equal to 1.24 times 10 to the power of minus, I think it's minus 4 volt. I don't remember the exact answer, but I could double check that. I have sent you the solutions. Now, the last part, part D, they ask for the speed of the wire. Delta V is equal to BL, the velocity or the speed. So the speed, isolating the equation for the speed, oops, I have delta V in here. So I have delta V, the induced voltage, delta V over B times L. If you sub in the values, you will end up getting 0.6 meters per second. Yeah. So one of the take-home message I would take from this example, what would be the direction of the induced current, and what would be which point on the rod will have a low V and which point on the rod will have a high V.